Hey everybody, in this video we are solving another trig equation. There's two other videos on this playlist already. This is the third one. The directions are different. Now they say solve each solve each trigonometric equation for all possible values in radians. All, forever, not just the answers between 0 and 2 pi. Use the hints provided. So here it says factor GCF. You cannot factor anything. Please say this to yourself a bazillion times. You cannot factor until your equation is equal to 0. You can also never divide both sides by cosine theta or x or something like that with throwing something away. All right? Unless you're dividing it and it's staying underneath and then, you know, it's staying a part of it. If you divide it and it crosses out on both sides, no bueno, no good. Okay, you cannot do that. So how do I get this equal to 0? That's first and foremost. I'm going to subtract cosine theta from both sides. The cosine theta that I am subtracting from both sides, do not be a rookie. It does not combine with what's already there. They are not like terms. This one has cosine theta, sine theta. That's like having xy, like 2xy. Then next to it, I'm going to have minus cosine theta, which is like minus x. And now it equals 0. Okay? So again, that's like looking at 2xy minus x, which is like a 1x equals 0. You can't combine them. Not like terms. Okay, so they stay the way they are. So now we're going to deal with the GCF. If you aren't totally clear on factoring GCF, don't be embarrassed. Please go to my factoring playlist, watch the video on GCF, get the full understanding of the fundamentals, especially if you plan on taking calculus in the future. Because when you do integration, you end up factoring the weirdest things in and out. So it's good to know. So here I'm going to factor out my greatest common factor. I can't do a C method. This isn't grouping. This isn't anything like that. This is not difference of two squares. This is a GCF situation. I like to underline the thing that I'm taking the GCF out of. What is the greatest common factor? It would be cosine theta. They both have a cosine theta. I like to underline it because I like to think of distribution as division, as multiplication. So factoring is like division. So I'm going to divide out the cosine, but you can't randomly just divide something out. So I would also think of it as I'm multiplying outside by cosine theta. So the thing I'm dividing out of the inside is really multiplying on the outside, and that's why I'm allowed to do it. It keeps the balance. It's like I'm multiplying by 1. Now here, this is going to reduce. So how does that reduce? Cosine, when cosine cross out, I'm left with 2 sine theta, okay? Then I'm going to do that same thing here. You could only do the pretzel method with sums and differences, not with multiplication, okay? With multiplication, if something reduces, it's just gone. That reduces to 1. It's not 0. Don't be that person, okay? Equals 0. Now that it's factored, each individual factor is prime. Okay, so it's like in example 1, I referred to them as being prime. Once they're prime, you could start solving, setting them equal to 0. All right, so I'm going to go over here. Cosine theta equals 0. Solve that. I mean, that's already set up, ready to go. Then we have 2 sine theta minus 1 is 0. I'm not going to show every single step right now. I hope we can all keep up. I'm going to add 1 and divide by 2. So that means sine theta is equal to 1/2. And now you ask yourself the magical questions, right? What angles are these describing? The cosine of what angle or angles will give me 0. Cosine is the x value. When is the x value 0? Here and here. Okay? Sine equals 1/2. Sine is the, because this is your x-axis. X is 0 here. X is 1. X is -1. X is root 3 over 2. Root 2 over 2, 1/2. -1/2. Negative root 2 over 2. Negative root 3 over 2. -1. Okay? So x is 0 here. Now what angles does it go with on the circle? Well, it goes with that and that. Over 0. Over 0. Okay? Where is sine equal to 1/2? That means up a little bit. Up a little bit. What angles are those? So that's what we got to write down next. Okay? So I'm just going to go to the side over here to kind of finish. Okay? So cosine of theta equals 0 when theta equals, well, for one thing, when theta equals pi over 2. Another one is 3 pi over 2. I'm going to start with the unit circle. It's like my baseline, my template, okay? And then where does sine of theta equal 1/2? There's also two answers there. One of them is when theta is pi over 6, and the other is theta equals 5 pi over 6. Now the directions said to find all answers. So that means I don't just want, for instance, this answer of pi over 6. I want every answer coterminal. Every answer, every loop-de-loop, around and around, every answer that would overlap that angle. So another time around, another time around, another time, going the other way, negative angles. So how do I get coterminal angles? Well, I add 2 pi. How many times do I add 2 pi? Well, any number of times I want. Once, twice, 0 times, -1, -2, 3 times, whatever. So I write plus 2 pi n. Underneath, somewhere you can write the phrase n is an integer, if you want to be kind of a rookie, if you ask me. Or you could write n is an element of, so it looks like that, the set of integers. So that's like the set of real numbers, has that r with the extra line, right? So I think that's cuter, okay? So there you go. And then you just write that every single time. And theta was already alone. Now, here, could I do each of these plus 2 pi n plus 2 pi n? I can. But if it's multiple choice, you need to watch out, because really these answers, I could do plus 2 pi n for both of them, but I could also consolidate these two, and I could just pick one of them, so say pi over 2, and instead of adding 2 pi n, I could just add pi n, because it's going to do the same thing. It's going to hit from top to bottom, back to top to bottom, back to top, So you could either leave it like that. If it's open-ended, it really doesn't matter. Or you can leave it like that, a little bit more consolidated. So if it's multiple choice, you just need to pay attention to what is going on. And that's the end of that example. So the next video, I'm going to do one that's more like an AC method. I'm not going to go into all the factoring. So again, if you need to watch a video on factoring, go to my factoring playlist. There should be the 5th video down. I think I've dragged it all the way to the top. I recently uploaded a full lesson on how to do AC method, where I break it down with the FML, FOIL, all that good stuff. Okay? So if you are doing okay, let me know. No, let me know. And check the playlist. Bye for now.